This is the second part of section 1 of chapter 1 of our statistics book. We're going to continue our discussion about different ways of interpreting data with graphs. This section is going to do two plot graphs. First one is a stem plot, or also known as the stem and leaf plot. A stem and leaf plot arranges data based on place value. So you can see the distribution of numbers based on their place value. It looks similar to like a histogram turned sideways where you have like the number of items represented, but you're actually given the values rather than just a graph. So let's take a look at the data. So if you have your Excel file open, we're in example 3. And this is the data set. This is the information from 1.9 of page 17 in your book, and it is the survey of study habits and attitudes of first-year women at a private college. So this is all the data, so you don't have to type it all in. One thing I would suggest that you do is take and highlight all of this information and put it in order. It's going to help us. You don't have to do any of this on your Excel. It does make it easier. So we're going to do column A. That's our only set of data, smallest to largest, and we're going to sort it out. You can also do a sort on your graphing calculator. So if you go to Stat, Edit, and put in a new list. So we'll just go to list 2. We don't have to put in the same values per se, because we're just going to show you how you can also sort them on your calculator. So these are the first few numbers on the list on from 1.9. If you do sort, see it says sort A, that's ascending and descending. We're going to do ascending. And we're going to sort, this one was list 2. So if I do second list 2 and enter, now when I go back into my list, see that they're now in order. You can also recall a list by just doing list 2 and pushing enter, and it'll give you the set of data also now in order. So you can do this on Excel or on your calculator just to put them in order. It's going to help us to have them in order. You don't have to have them in order. You can just cross the numbers out as well. So I notice my lists are all in the 100s. So what a stem and leaf plot looks like is we're going to put the beginning numbers on the left and the ends on the right-hand side. Let me get both these screens next to each other, and you can, there we go. So we are going to have a line to distinguish the stems from the leaves, kind of like a tree. And our stems, in this case, are in the 100s. So I'm going to do by tens. So 100, 110, 20, oops, 30, 40, 50, 60, 80, and there is a 200. And you can also write all of this out by hand. So now if I'm looking at my list to the right, so that's my reference point, I have 101, 103, and 109. So those are my leaves. So now when I look at just this first set, I can see, let me line it up better. I have 101, 103, 109. Let's move on to the 100. Well, there's in the tens place, there's only the 15. In the 126s, there's a 6, a 6, and a 9. 137, 140, and 48. 152, 54, I have 2 of those. 165, 165, 178, and then 200. So this is what the stem and leaf plot would look like for the data for 1.9. Let's talk a little bit about this information. This 200 seems very much out of place. This is what we would call an outlier because it doesn't really fit the rest of the data. This also, so looking at it gives you an idea of how the information is being spread out. You can also use these as decimal places. So if this was representing a different data set, it could also be 10.1, 10.3, 10.9, etc. Or 11.5, 12.6, etc. And I think that's all that I have for this one. Oh, a stem plot does represent quantity. So in order to do a stem plot, you do need numbers to work with. So it's a quantitative study. Let's now take a look at a similar idea, which is a time plot. So a time plot reveals or can reveal changes over time. So you're graphing out the data based on the time at which it was measured. So that could be a year or really any, I guess, any set of measurement, so minutes or days or hours even. These do look more kind of like a linear graph. So we're going to go to example 4 with 1.4. This is 1.10 on page 19 of your textbook is where this data is coming from. And we're going to use our Excel to graph these. You could graph them by hand as well. It's similar to what we'd call a scatter plot, which we'll get into soon. But we're going to insert, and we're going to do a line graph. And let's do one of them with markers so we can tell what is happening. So if we do that, we do need to change our data because right now it's graphing both of them. Let's just remove both of these. And we're going to add, so our series legend, if we just are our years. Yep, sorry. Let me try that again. Our horizontal are our years. And our values let's just start over here. Because it's doing 2 of them separately and I don't want them individually. There we go. So we want to change our horizontal axes to our years. So here it should be all of the years. And if it doesn't, you can do edit, change, or edit, and then highlight those. And we do want these to be our series 2. If you want to rename them, this is the rate of the money market funds. And let's make this a little bigger. There we go. So we can see the years. and what's happening. So you can change the scale. And again, you can change the colors up here at the top. You can fill in shapes with different colors or even pictures if you want. So those are things that are there. You feel free to play around with it. So this would be our time plot for money market funds. And it looks like, if we want to talk about some of the patterns, because you're supposed to evaluate, well, what did you find when you did these? So it looks like it's going up and then now it's going back down. So it kind of does a cycling, sort of, where it's going up and down, up and down, up and down. In 1981, so if I highlight over it, it tells me 1981 does seem to be a spike. So it doesn't really fit in there, but it does seem to be a spike, or also called a peak. After that, it does look like, although it's cycling, the overall trend is downward.